assigning values and applying functions. So let's take a situation where you're a data scientist and you'd like to know the impact of how different generations in age and what that outcome is on marketing campaigns. Now, age right now in the data set is a continuous variable. So the workaround is that we want to convert this into 4 different categories for the next level of analysis. So how about we create those categories using different generations? And we'll say that Generation Z are people born 1996 and later. Generation Y are people born between 1977 to 1995. Generation X are people born between 1965 to 1976. And the baby boomers are born between 1946 to 1964. So what we want to do is we want to read in bank customer using the read CSV function with a file called demo2 assigning values and applying functions. We run that. It looks like it ran. Okay, perfect. Now, we might want to view that. So we go to view bank customer. And here we have that data. Now, one of the things we probably want to do is actually rename the age variable, because it looks like in this data set that age, instead of just being age, is I.age. Well, if we want to do that, the easiest way is using an external package called plier. So we want to install that package, and it looks like I already have it installed. So if you do, then it may give you this warning message in regards to one or more of the packages that will be updated by this installation are currently loaded. Restarting R prior to updating these packages is strongly recommended. So because I already have it installed, I don't need to do that. But make sure that you install the plier package. After that, we'll load plier using the library function. And now what we want to do is go to bank customer. We want to rename within the bank customer data frame and convert I.age as equal to age. So we want this to be the new variable. Well, we run that, and it says the following from value is not present in x I.age. So let me look back here. Well, there's actually an umlaut over that I. So if you don't know an easy way to get to the umlaut function, then what we could do here is go to the structure, and here we have I.age with the umlaut. We can copy and paste that into here. So now we run that, and now maybe we look at bank customer view, and now we see here's age without the umlaut I, ... but just age capitalized. So that's perfect. Now, we might also want to make sure that the data is accurate. So there's a variety of ways of doing this, but 2 things we should obviously look at are the max and minimum values. So the way to do that, max is the function, bank customer is the data frame, and then within that, we have age. So the way the syntax specified is its function, data frame, use the $, which denotes that we're going to look at the column name following that $. So if we run that, we see that the max age is 87. Well, we probably also want to do this for the minimum, make sure there's not something erroneous like negative numbers or 0. So we run that. The youngest age is 19. Okay, that's perfect. So if we think back to the previous step of grouping these by generations, we have 4 different generations. So Gen Z will be age from 0 to 22. Generation Y will be 22 to 41. Generation X will be 41 to 53. And the baby boomers will be 53 and above. So what we want to do here is, let's say we take bank customer age categorized, and we want to transform this continuous variable into these factors, into these groups. So we go to transform, bank customer is that data set, and we say generation equals, and let's actually do if-else statements. So we say if-else, the age is less than 22, they are generation Z. If-else, age is less than 41, because this goes sequentially, so it checks first for age less than 22. If that doesn't occur, it moves to this next one. If else, age is less than 41, then Y. And I'm sure you understand what we're going to do here. If else again, age is less than 53, then generation X. Otherwise, let's call them baby boomers. So we run that. Perfect. And we can look at bank customer age categorized, which you can see shows a sample of that data frame. We still have age here and whatnot, but now we have this generation variable at the end. And so we can see from the sample that there's Ys, there's baby boomers, there's X, there's a Z. So it looks like our function worked. So this new variable has been created and the data is now ready for analysis. And we want to establish a relationship between the previous marketing campaign, that variable P outcome, with this categorized age variable generation here. So one way we could potentially do that is through a two-way frequency table. So we say, let's create a table with the bank customer age categorized, which is our new data set, which has a new variable. And as you can see, this one here is bank customer age categorized, and there's 16 variables now instead of 15. So we still have the original bank customer data frame, but now we have this additional data frame in R as well. So we go to table, we say bank customer age categorized, $generation to get to that variable. And we say bank customer age categorized P outcome. Because what this table is going to do is look at one variable against another. So we run that, and we can see here, we have baby boomers X, Y, and Z, and then we have the other factors within P outcome as failure, other, success, and unknown. Now it does look like there's a lot of unknowns, but you can see that perhaps Gen Y has the most failures. On the other hand, they could have the largest number of people in there, and probabilistic-wise, they're relatively similar. But based on these table results, we can likely conclude that baby boomers and Generation Z are more likely to have higher conversion rates and react positively in marketing campaigns than Generation Z and Generation Y.